most accounts of industrial history, the large mine pump appears as a technical necessity. Water accumulated in early modern mines at depths that manual labor could no longer manage. Buckets, drainage adits, and horse-powered systems reached their limits. Extraction stalled not because ore was exhausted, but because water could not be removed fast enough. The arrival of large-scale pumping engines is therefore presented as a rational response. Steam power entered the mine not to transform society, but to solve a practical constraint. The logic appears straightforward. Remove the water, deepen the shaft, increase output. In this telling, the pump is neither dramatic nor controversial. It is a problem-solving device. It expands access to coal and metal deposits that would otherwise remain inaccessible. Its scale reflects the scale of the obstacle. Its fuel consumption is justified by the value of the resources it unlocks. Industrial museums, engineering textbooks, and public histories often describe these engines as milestones. The rocking beam above the shaft, the massive cylinder, the steady rhythm of steam-driven motion. These elements symbolize mechanical confidence. The machine appears disciplined, predictable, and purposeful. Students learn that without effective drainage, deep mining would have been impossible. Without deep mining, the energy supply that powered factories, railways, and steamships would have remained limited. The pump is therefore positioned as foundational. It is not celebrated for aesthetic beauty, but for functional importance. In diagrams and technical descriptions, the focus remains on efficiency. Improved fuel economy, stronger components, higher lifting capacity. The machine's growth in size is framed as progress in engineering competence. Larger pumps reflect deeper mines and expanding industrial ambition. The broader social context is usually mentioned only briefly. Mining communities grew. Output increased. National industries strengthened. The machine becomes part of a larger sequence. Steam engine, mechanized factory, railway network, global trade. The story carries an implicit assumption. Technology responds to need. Society adapts. Progress accumulates. Within this structure, the mine pump occupies a stable position. It drains water so that industry may advance. It appears as a neutral intermediary between natural resource and economic development. Yet the scale of these machines raises a quieter question. If the pump was merely a technical solution, why did its expansion coincide with intensified labor discipline, rising capital concentration, and the integration of remote mining districts into imperial supply chains? The more closely the massive mine pump is examined within its working environment, the less self-contained it appears. Draining water from deep shafts did not simply expand access to mineral seams. It altered the geometry of labor underground. As pumping capacity increased, mines descended further below the water table. Depth was no longer a natural limit, but a technical challenge. With each additional level, air circulation became more complex. Travel time between surface and working face increased. The margin for error narrowed. Productivity figures recorded steady gains. Tonnage extracted per year rose in districts that invested heavily in drainage. Yet these numbers conceal a parallel shift. The deeper the mine, the more workers depended on continuous pumping. The machine was not an auxiliary device. It became the condition of possibility for survival underground. When a pump stalled, water accumulated quickly. Even temporary failures could halt production. In some documented cases, flooding trapped workers for hours or days. In others, shafts became unusable for extended periods. The cost of interruption was financial, but also physical. The machine's reliability defined the boundary between routine labor and emergency. Maintaining such a system required its own hierarchy. Engine men monitored pressure and motion. Boiler attendants fed furnaces continuously. Mechanics inspected valves and seals. Coal was consumed to power the pump so that more coal could be extracted. The system fed on itself. This circular dependency encouraged continuity. Owners who invested substantial capital in large pumping engines had little incentive to pause operations. The expensive installation demanded constant output. Shifts became regularized. Time discipline hardened. Where earlier forms of mining had allowed for seasonal variation or intermittent work, deep mechanized mines required predictability. The pump also restructured authority. Underground workers could not independently assess the status of drainage systems. They relied on signals from the surface. Decisions about maintenance schedules, repairs, and shutdowns were concentrated among managers and engineers. Control over the machine translated into control over the rhythm of work. At the same time, technological improvements did not eliminate hazard. In some regions, the expansion of deeper mining increased exposure to explosive gases and structural instability. Pumps removed water, but they did not remove methane. They stabilized one variable while intensifying others. Environmental effects extended beyond the shaft. Continuous drainage altered groundwater patterns. Surface wells occasionally ran dry. Land subsidence followed the extraction of deeper seams. These outcomes were rarely foregrounded in engineering reports. They appeared instead in local complaints or agricultural records, peripheral to the central narrative of industrial expansion. Another tension lies in the distribution of benefit. Large-scale pumps required significant capital investment. Smaller operators often struggled to finance such machinery. Consolidation followed. Mining districts increasingly came under the control of companies capable of absorbing installation costs. Technological advancement coincided with concentration of ownership. None of these developments negate the pump's functional success. It worked. It drained. It enabled extraction that would otherwise have been impossible. But its success generated dependencies that extended far beyond water removal. The machine did not merely expand production. It tied labor, capital, and landscape into a tighter configuration. It reduced certain constraints while amplifying others. In public accounts, this complexity is often compressed into a single phrase: increased efficiency. Yet efficiency for whom and under what conditions remains less frequently examined. By the time large pumping engines became standard features of deep mining districts, they had already acquired symbolic weight. In engineering journals and public exhibitions, massive beam engines were presented as triumphs of rational design. Illustrations emphasized symmetry, proportion, and mechanical elegance. The pump was framed as evidence that human ingenuity could overcome natural barriers. Water, once a limiting force, was reclassified as a manageable obstacle. This framing gradually fed into a broader claim that mechanization in mining represented a form of liberation. Workers were no longer required to haul water manually. Flooded seams could now be accessed. Output increased. Industrial society advanced. Yet this interpretation rests on selective emphasis. Manual drainage may have declined, but labor did not. It intensified and reorganized. Deeper shafts required longer shifts underground. Travel distances expanded. The time spent descending and ascending increased. The physical burden shifted from hauling water to navigating depth and managing mechanized systems. The language of liberation often overlooks the fact that mechanization expanded the scale of extraction. Removing one bottleneck did not reduce overall strain. It allowed production to accelerate. The pump eliminated a constraint, but in doing so, it enabled a more demanding regime. Contemporary mining reports complicate the idea of rapid transformation. In many regions, Steam-driven pumps coexisted with older systems for decades. Adoption was uneven. Some mines delayed installation due to cost. Others experimented with hybrid drainage methods. The transition was gradual, negotiated, and dependent on local conditions. Retrospective narratives compress this complexity. They describe the arrival of steam pumping as a decisive turning point. The timeline becomes cleaner than the archival record suggests. What was incremental appears revolutionary. There is also a tendency to standardize loss. Mining accidents continued well into the age of advanced drainage. Explosions, collapses, and structural failures did not disappear with the installation of larger pumps. In certain cases, the scale of disaster increased because deeper mines concentrated more workers in confined spaces. Official investigations frequently documented such events in technical language. Reports analyzed mechanical failure, geological instability, or ventilation deficiency. Over time, these incidents became statistics. Fatality numbers were recorded, compared, and contextualized. The human dimension was translated into measurable data. In popular industrial histories, the long arc of improvement often overshadows these intervals of instability. Safety reforms, ventilation systems, and regulatory frameworks eventually emerged. The narrative moves toward resolution. Early hardship is treated as transitional, yet the duration of this transition spanned generations in some districts. Mechanization did not immediately produce safer or shorter working lives. Improvements were uneven and often the result of labor agitation rather than technological inevitability. Another distortion concerns tempo. Industrialization is frequently described as accelerating. Once steam entered the mine, growth appears unstoppable. However, production records reveal cycles of expansion and contraction. Markets fluctuated. Infrastructure investments sometimes exceeded demand. Pumps stood idle during downturns, despite their imposing presence. The image of relentless progress simplifies a more fragile reality. Different types of sources reveal these discrepancies. Engineering treatises emphasize mechanical refinement. Investor reports focus on output and return. Workers' testimonies describe fatigue, risk, and dependence on machinery they did not control. Later academic research attempts to synthesize these perspectives, but public memory often privileges the cleanest narrative. The pump becomes a milestone in a sequence of achievements. Steam engine, factory system, railway expansion. Its role is defined by contribution to growth. The conflicts and negotiations surrounding its operation recede into footnotes. This simplification serves practical purposes. A linear story of innovation is easier to teach and easier to integrate into national narratives of development. Complex interdependencies between labor discipline, capital investment, and state interest are harder to summarize. The result is not fabrication but reduction. The massive pump is remembered as an emblem of progress. It drained water so that industry could advance. It symbolized mastery over environment. It represented technical competence. What fades from view is the structural transformation that accompanied it. The tightening of labor schedules, the consolidation of ownership, the exposure of entire communities to the volatility of deep extraction. The machine's motion appears steady and rhythmic in diagrams. The social consequences of that motion were less predictable. To treat the pump solely as a liberating device is to isolate it from the network of decisions and pressures that sustained it. To treat it solely as destructive would be equally incomplete. What becomes evident, however, is that the history of mechanized drainage has been streamlined. Its complexity has been compressed into a narrative of inevitability. The pump did not simply remove water. It recalibrated the balance between depth, labor, capital, and risk. As mechanized drainage became more reliable, its significance extended beyond the mine itself. Coal and metal were not only commercial goods, they were strategic resources. States increasingly measured their strength in terms of energy supply, transport capacity, and industrial output. In this framework, deep mining was not a local matter. It was a component of national infrastructure. Large pumping engines contributed to this infrastructure by stabilizing extraction. They reduced the likelihood that mines would be abandoned due to flooding. They allowed planning on a larger scale. When output became more predictable, contracts could be secured, railways supplied, and naval yards provisioned with greater confidence. This predictability had political value. Governments invested in transport networks that connected mining districts to ports and industrial centers. Railway expansion often followed coal seams. Ports expanded to accommodate bulk export. The pump, though physically stationary, became part of a mobile system of distribution. Public discourse began to equate industrial capacity with modernity. Regions that successfully deployed advanced machinery were described as progressive. Those that did not were portrayed as backward. Mechanization became a marker of civilizational status. The association was not accidental. Industrial output supported military logistics. Steam-powered navies depended on reliable coal supplies. Rail networks enabled rapid troop movement. In such contexts, the ability to extract resources efficiently was framed as a national necessity. Pumping technology was also exported. Engineers trained in one mining district applied similar systems in colonies and foreign concessions. Steam engines were shipped abroad. Technical expertise accompanied imperial expansion. The same mechanisms that drained water in domestic coal fields were installed in distant territories, often under different labor regimes. In these environments, the relationship between machine and worker could be more sharply unequal. The pump's technical neutrality did not determine how labor was organized around it. That organization reflected political hierarchy. The narrative of modernization helped justify these processes. If mechanization represented advancement, then its spread could be described as development rather than domination. Infrastructure projects were framed as civilizing efforts. The economic logic of extraction merged with the language of improvement. Domestically, modernization narratives also provided cohesion. Rapid industrial transformation disrupted social structures. Rural populations migrated to mining towns. Traditional forms of livelihood declined. Framing industrial expansion as collective progress offered reassurance. It suggested that upheaval served a larger trajectory. The monumental scale of pumping engines reinforced this message. Their size conveyed permanence. Their brick engine houses resembled civic buildings. They were not temporary tools. They were statements of capability. This symbolic dimension reduced friction. Celebrating technological achievement diverted attention from distributional conflicts. Questions about wages, working hours, and environmental degradation could be overshadowed by visible evidence of mechanical power. Again, this does not imply deliberate concealment. Political leaders and industrialists often believe sincerely that mechanization served national interest. The benefits were tangible. Increased output, urban growth, expanded trade. Yet convenience shapes narrative. A story centered on ingenuity and national strength is more stable than one centered on labor dispute and ecological alteration. The pump fits comfortably into the former. It is harder to integrate into the latter without complicating identity. Educational materials frequently reflect this preference. Inventors and engineers are named. Dates of installation are recorded. Production figures are cited. Less attention is given to the administrative frameworks that enabled consolidation of ownership. or the legal structures that regulated labor. In this way, the pump becomes emblematic. It stands for an era of expansion. It anchors a story of ascent, but its operation was inseparable from policy decisions, credit systems, and geopolitical ambition. The machine did not build empires alone. It functioned within strategies that linked extraction to state power. When presented as a purely technical device, the pump appears neutral. When situated within the political economy of the 19th century, it appears embedded. The difference lies not in new evidence, but in perspective. Beyond the dominant narrative of engineering success and national development, a different archive remains. It is found in inspection reports, accident inquiries, maintenance logs, and company correspondence. These materials rarely attempt to tell a grand story. They are procedural, technical, sometimes terse. Yet taken together, they reveal the fragility underlying the image of mechanical mastery. Mining inspection records from the 19th century frequently note the condition of pumping systems. Boilers required constant cleaning to prevent scale buildup. Cylinders leaked. Valves stuck. Wooden beam components warped under strain. Even in well-funded operations, the pump demanded vigilance. The machine's scale did not eliminate vulnerability. It redistributed it. When failures occurred, they were often described in mechanical terms: pressure imbalance, cracked piston rods, insufficient fuel supply. Yet the consequences extended beyond equipment. Production halted. Wages were suspended. In certain instances, flooding damaged not only the shaft, but also adjacent infrastructure, requiring months of repair. Financial ledgers provide another perspective. Installation costs for large drainage engines were substantial. Investors expected returns. Debt obligations tied mines to output targets. In correspondence between owners and managers, one can trace concern not only about geological uncertainty, but about the repayment schedules associated with machinery. This economic pressure shaped operational decisions. Maintenance might be delayed during periods of low profit. Expansion into deeper seams could be accelerated to justify capital expenditure. The pump, once installed, exerted its own momentum. It encouraged continuity. Labor reports add further complexity. Testimonies from miners occasionally mention the constant sound of the engine above ground. The rhythmic motion of the beam was not abstract. It signaled that water was being managed. Silence could generate anxiety. Strikes in certain coal districts reference the intensification of work that accompanied deeper mining. Demands for shorter shifts or improved ventilation were not directed at the pump itself, but at the system it enabled. Mechanization had increased capacity without automatically improving conditions. Environmental documentation, though less centralized, also appears in scattered sources. Agricultural complaints about altered water tables surface in regional records. Subsidence reports document gradual sinking of land above heavily worked seams. These outcomes were rarely attributed solely to drainage systems, yet they formed part of the cumulative transformation. Technical manuals emphasize the necessity of redundancy. Backup systems were recommended where feasible, yet redundancy required further capital. Smaller operations often lacked such safeguards. When a primary pump failed, consequences could escalate quickly. None of these materials deny the pump's contribution to industrial expansion. They do, however, complicate the image of inevitability. The machine appears less as a stable monument and more as a demanding infrastructure requiring constant negotiation between cost, risk, and output. The absence of these details from mainstream narratives reflects selection rather than suppression. Technical fragility and financial strain do not fit easily into celebratory accounts. They introduce uncertainty into stories of confident ascent. When one reads across inspection records, financial correspondence, and worker testimony, a more contingent picture emerges. The pump enabled depth. Depth increased dependence. Dependence required discipline and capital. The system functioned, but not effortlessly. The idea that such machinery built empires becomes less declarative and more conditional. It supported expansion, but only within networks of credit, regulation, and labor that were themselves unstable. The archive does not overturn the dominant narrative. It reframes it. The massive pump was powerful. It was also precarious. The massive mine pump does not need to be recast as a villain in order to be reconsidered. It performed a clear function. It removed water from shafts that would otherwise have flooded. It extended the depth at which extraction could occur. It contributed to the energy supply that supported industrial expansion. These facts remain intact. What becomes less secure is the framework that treats such machinery as a neutral engine of collective advancement. When examined within its full context, the pump appears as a component in a larger configuration of capital investment, labor discipline, environmental transformation, and state strategy. Its operation required continuous fuel, supervision, and maintenance. Its installation reshaped ownership patterns. Its reliability determined the safety of workers who descended into depths made possible by its motion. Its scale encouraged permanence, yet its function depended on fragile mechanical balance. To say that it crushed its own crew need not imply a single catastrophic event. It can describe a structural condition. The deeper the mine, the greater the dependency on uninterrupted drainage. When that dependency faltered, the consequences were immediate and unevenly borne. To say that it built empires does not mean that a beam engine alone generated geopolitical expansion. It suggests that mechanized extraction contributed to the material foundations of state power. Reliable coal and metals supported transport networks, naval capacity, and industrial production. The pump formed one link in that chain. What remains uncertain is how much of this process was perceived as inevitable. Historical narratives often present industrialization as a sequence of necessary steps. Water obstructed extraction. The pump solved the problem. Growth followed. Yet each stage involved decisions about investment, risk tolerance, labor organization, and regulatory oversight. The machine did not dictate these choices. It operated within them. When industrial history is streamlined, complexity gives way to clarity. Invention replaces negotiation. Progress replaces conflict. The pump stands as a symbol of mastery rather than as an instrument embedded in competing interests. Reintroducing context does not reverse the story. It complicates it. The pump remains important, but its importance becomes conditional rather than absolute. Its legacy is visible in abandoned engine houses, altered landscapes, and the industrial networks that outlived it. These traces do not offer a single interpretation. They invite reconsideration. If technological achievement is neither wholly emancipatory nor wholly destructive, then the question shifts. When we encounter the monumental machinery of the past, are we seeing evidence of inevitable progress, or the visible residue of decisions whose consequences we have only partially understood?